Our next assignment, 21, 5.6, the quadratic formula and the discriminant. Your essential question, how do you solve quadratic equations using the quadratic formula, and how is the discriminant used? So in Algebra 1, you probably worked quite a bit with the quadratic formula, and today I'm going to take that a couple of steps further. So the first thing I want to do is I want to derive the quadratic formula for you. You do not have to memorize how to derive the quadratic formula, but it's kind of interesting to see where it all comes from. All right, so we are going to derive the quadratic formula. And we're going to start off with a quadratic equation in standard form. So I'll start with ax squared plus bx plus c equals 0. Okay, and I'm going to actually end up completing the square on this. So I want to get rid of the c. Take that to the other side. And then I want to make sure that my a is equal to 1, or that I should say that whatever the coefficient of x squared is equal to 1. So I'm going to just be safe here and divide out that a. And from there I'm going to complete the square. So now this could get a little bit tricky. I am going to add to both sides. I have to take this b over ax. I have to divide that by 2 and square it. So dividing b over a by 2 is going to be a little bit tricky, and hopefully you realize that dividing by 2 is the same thing as multiplying by a half. So I'm actually going to do 1/2 of b over ax, and I'm going to square that. Not the x, just the b over a, because that's the coefficient. And whatever I do on one side, I have to do to the other side of the equation. Okay, so from this I'm going to get, now this becomes basically b over 2a squared. And I can simplify it on this side. So on this side it's going to be b squared over 4a squared. Now from there I can go ahead and write the left-hand side as the square of a binomial. So my first term is x, right, the square root of that. And then my last term is going to be b over 2a. And I'll take the sign of the middle term. Now on this side we're going to need to do some simplifying. So I'm going to need to multiply this by 4a, both top and bottom, so I can get common denominators. Adding to that, your b squared over 4a squared. So now I'm just going to simplify the right-hand side so that I have x plus b over 2a, whole thing squared, equals, and I think I'll go ahead and take the b squared and then subtract the 4ac. And put that over 4a squared. Now my goal is to get x by itself, because believe it or not, the whole reason for using the quadratic formula is to solve a quadratic, which means find the x-intercepts. So I need x all by itself. So I'm going to now square root both sides. So I get x plus b over 2a equals the positive or negative, and it's basically the square root of this whole entire side. Well, I notice that I can basically do nothing with the numerator, so I'm going to leave it as the square root of b squared minus 4ac. But on the bottom, if I take the square root of 4a squared, I will get 2a. From there, I'm going to get x alone, so I'm going to subtract this b over 2a. And then I can also combine these into basically one number. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And what we have just came up with there is the actual quadratic formula. So this right here is the quadratic formula. This should look familiar to you. You've probably used this before, most likely in Algebra 1. I would highlight this. You need to memorize this. This is something that you need to have memorized. I'll show you some videos in class of songs that maybe you can memorize the songs. But definitely this would be something that you'd want to have on a note card, on any test from here on out. And it's just easier to just memorize it. So let's do an example using the quadratic formula to solve. For me, the quadratic formula is something that I use at the very end. If I can't factor, if I can't use square roots, I would probably use it before I did completing the square. But it's kind of my last resort. It can be used whenever you want. As long as you have a quadratic equation, you can use it to solve. And for some people, they just really like to have that ability to fall back on the quadratic formula whenever they want. Okay. So the first thing, okay, well actually here, let me give you the problem. 5x squared minus 2x plus 37 equals x squared plus 2x. Alright, so the first thing you always want to do is not treat this quadratic this way. You want to deal with this when it is in standard form. So my job right now is to basically get everything onto one side, set it equal to 0. So I'm going to subtract x squared, which will give me 4x squared. And I'll subtract that 2x, which will give me negative 4x, plus 37 equals 0. Now, I could spend all day long trying to figure out factors of 4 and factors of 37 that their sum will give me this negative 4, but that's never going to happen. So I'm going to go ahead and use the quadratic formula. For the quadratic formula, you need to identify what your a, b, and c are. So my a, which is the coefficient of x squared. B is the coefficient of x, which is negative 4. And c is my constant, which is 37. And then all I do is I take those and plug them into the quadratic formula, which, if you haven't memorized it yet, negative b plus or minus the square root of b squared minus 4ac all over 2a. And now you just start plugging things in. Realize there's a plus and a minus, right? So there's going to end up being potentially 2 answers. We'll talk more about that in a second. So negative b, well that's a negative 4, plus or minus the square root of b squared, well that's negative 4 squared, minus 4 times c, which is 37, all over 2 times a, which is 4. Okay, so I'm going to have 4 plus or minus the square root of, well, that's going to be 16. And multiplying these together, I get negative 592 all over 8. Alright, so continuing simplifying, this is 4 plus or minus the square root of, and 16 minus 592 is going to give you a negative 576 all over 8. Okay, and this is why we learned about complex numbers, because before then you could not take the square root of a negative, but now you can. So it's going to be 4 plus or minus, I know I'm going to have an I here. And then I need to think about what the square root of 576 is. And it actually is a perfect square. So it's going to be 24. And it might be better if I wrote this instead of I times 24, if I write it as 24I. It's a little bit more user-friendly that way. It's kind of similar to every time that we use variables, we have terms. All right, so now I'm going to look for a greatest common factor here that maybe I could reduce out with the bottom. So 4 and 24 have a greatest common factor of 4. So I'll factor that out. I'll be left with 1 plus or minus 6i all over 8. And then 4 and 8 can be reduced. Okay, so I'm getting two values here for x. One of them is going to be 1 plus 6i over 2. And the other one is going to be 1 minus 6i over 2. Or in other words, you could leave it as 1 plus or minus 6i divided by 2. Okay, so this would probably be how I would leave my answer. I can't graph this, right, because these are in the imaginary realm, and we're only going to graph on the real number plane. So this would be my answer. Now, if there was no I here, I would then take this and I'd put it into a calculator and I'd get some exact answer or some approximate answer so that I can graph it. So continuing on, let's talk about the discriminant. The discriminant comes from the quadratic formula, and it's basically that part of the quadratic formula that is underneath the radical. So it's the b squared minus 4ac. And the reason why this becomes so important is it tells us how many solutions are, or how many real solutions our quadratic equation can have. So for example, in example 1 that we just finished, my discriminant here was negative. So when I graph this, I'm actually not going to have any x-intercepts because they are complex numbers. And we only graph these in the real plane. Okay, so the discriminant is basically used to determine the number and type of solutions. Are they real? Are they complex? And therefore we can't graph them. Okay, and so there's basically 3 choices, and this comes from problem number 3 from chapter 5, section 3 that we did a couple days ago. And it basically says that if the discriminant, so if b squared minus 4ac is greater than 0, is equal to 0, or is less than 0, then we're going to have different numbers and types of solutions. So if it's greater than 0, that means I'm going to have 2 real solutions, because then that means I can actually take the square root and get something. And so a graph of this might end up looking really familiar to you. It's just going to be a parabola that crosses the x-axis twice. Okay, now what happens if the discriminant actually equals 0? Well, think about it. In this formula, if you take the square root of 0, then you're not going to plus or minus 2 different numbers. You're basically adding or subtracting 0, which is just going to mean that you're going to have a root where negative b over 2a is what it is. So here you're going to have 1 real solution. And as I probably drew the other day, that could look something like, if this is the x-axis and the y-axis, maybe let's have one that's just pointing down. Right? So it's got 1 solution, and it's probably going to be where the vertex is. All right, and then the last one is what happens when our square root has a negative under it, like example 1. Well, how many real solutions did we have? We didn't have any real solutions. Okay, so we're going to have 2 imaginary or complex solutions, which again, the graph of that will probably be a parabola out in space somewhere. So how about if I come over here? It's never, ever, ever going to touch the x-axis. It could potentially go through the y-axis because if I extend this long enough, it'll come over. But it will never, ever have any x-intercepts. Okay, so that's what the discriminant tells us. So a lot of times before you start plugging and chugging with the quadratic formula, it's a good idea to know, well, how many solutions am I actually looking for? Or sometimes it's good to know just if you want to start factoring it and it's not factoring. Or you'll see in a couple of chapters here, I'm going to show you some really complex polynomials that you're going to want to solve, and it's going to be really important to try and figure out how many solutions there might be. Okay, so let's do an example with this one. Using the discriminant. So we'll use the discriminant to determine the number and type of solutions. So let's do our first one here, A. So if I have 4x squared minus 4x plus 1. Now remember, everything that we're doing, things need to be in standard form. Okay, so 4x squared minus 4x plus 1 equals 0. That is in standard form. And to try and figure out the number and type of solutions, I'm just going to use b squared minus 4ac. So I guess it's going to be important to tell what is A, what is B, what is C. Just plug those in. So b squared is going to be negative 4 squared minus 4 times A is 4 times C is 1. So I'm going to have 16 minus 16, which is going to equal 0. Okay, so if I get a 0 for my discriminant, that tells me that there's just going to be one real solution. So I know that there is going to be one real solution. You can find that real solution by using the quadratic formula, plugging everything into that and figuring out what the actual x-intercept is. All right, let's do one more of those. How about if we do negative 2x squared plus 3x minus 7. So again, identify your A, B, and C. A is negative 2, B is 3, C is negative 7. And then I just plug it into b squared minus 4ac. And what's beautiful about this is if you end up, like for example, this answer here where I got 0, if I needed to use the quadratic formula to actually solve it, well then the part that's underneath my radical, that's already been figured out for me. That's 0. So really I'm just going to have negative b over 2a, and that's going to give me my x value. Okay, so b squared minus 4ac, let's see, I'm going to do a 3 squared minus 4 times a is negative 2 times negative 7. So I get 9, and that's going to be minus 56. So that's going to end up giving me negative 47, right? 9, 56, yep. So negative 47. So my answer then is negative. If I end up with something less than 0, I'm going to have two imaginary solutions. Or complex would be another way that you could describe this. Or non-real would be another way that you could describe this. So I'm not sure how the back of your book does it, but imaginary, non-real, or complex.